good morning. Today we are going to apply an example based on the theory that we have taken. So I'm expecting you today that you do some work yourself. I will help you, but I'm expecting you to do some work. So the example is about calculation of diffusivity by the Wilke-Lee equation with known values of the Lennard-Jones parameter. This is based on my last lecture. So let's read the example. The example says, estimate the diffusivity of allyl chloride, which has a structure of C3H5Cl in air at 298 Kelvin and 1 bar using the Wilke-Lee equation. The experimental value reported by Lugg in 1968 is 0.098 centimeters squared per second, and the normal boiling point of temperature for the allyl chloride is Tb equals 318.3 Kelvin, which was reported by Reed et al. Paper in 1987. All right, let's read it again and make it more clearer. So basically what we want to do is finding the diffusivity, the capital D. When we took it last lecture, we said it should be capital DAB. So you have to make it clear now that A is basically allyl chloride and B is air. So in the paper, in piece of paper that you have, you will write for me A is allyl chloride and B is air. Now, he wants you to use the Wilke-Lee equation. If you go to the notes, you will see this equation. Wilke-Lee equation. I think it was the last slide. So look at it. It's telling you diffusivity of A into B, allyl chloride into air, is equal to constant 3.03 minus 0.98 divided by MAB to the power half. We said M is molecular weight. So, but it's not molecular weight of A, it is not molecular weight of B, it is both of them. And if you remember, we had this equation. The first equation on your right hand side, it's written MAB is equal to 1 over MA plus 1 over MB to the power minus 1. So that's MAB. Multiplying by 10 to the power minus 3, multiplying by the temperature. The temperature in the system was given to you. It is 298 Kelvin. And according to the parameter, it should be in Kelvin. Then divided by pressure. Pressure is given to you in your question. It is 1 bar. So 1 bar, and it should be also, if you go and see the units for pressure, it should be in bar. Then again, multiply by the molecular weight of MAB to the power half, multiply by the sigma, but it's not sigma A alone, or it's not sigma B alone, it's sigma AB to the power 2. And the last thing is the omega D. So you have to find each one of them separately, then you have to put them in the equation and you find the diffusivity of AB. So that's the whole thing. All right, so now MAB, that means you have to know the molecular weight of allyl chloride, molecular weight of air. Air you already know, it is 29. So you need to now to calculate based on the structure which is given to you of C3H5Cl, the molecular weight for allyl chloride. Calculate it yourself. It should be 76.5. So you calculate it If you don't know any one of them, go to the periodic table and find the values. But the molecular weight of of your allyl chloride should be 76.5. I suggest you divide your paper into two parts. You take A on the left and B on the right, and then you calculate for each one of them. Okay, so you did this, the first one, which means you are able to find the MAB. If you do that, now what you need is to find the sigma AB. How can you find the sigma AB? Well, sigma AB is written to the first equation and the first equation and the first one, sigma AB is equal to sigma A plus sigma B over 2. And you already put A is allyl chloride, B is air. So which one we have now? We have to go to the tables. The table here, Appendix B, if you look, the one that you have is the air. Sigma for the air is 3.620. So that's given to you. So you just take it and you put the angstrom as a unit, and that's that. So what about sigma B or A, allyl chloride? Well, to calculate that, you need to use this equation, the second equation, below the diffusivity. Sigma, you see it? It's equal to 1.18 multiplied by VB to the power 1 over 3. So if you want to find the sigma of allyl chloride, that means you need to find the value of VB. So how can we find the value of VB? To find that VB, you have to use table 1.2, which is atomic value contribution of the elements, and based on the composition of your compound. So we said it's basically allyl chloride is C3H5Cl. So 3 carbons, 5 hydrogen, and 1 chlorine. So you will go to this table. You take carbon was 3, we said, 3 multiplied by 14.8, and then you do the rest also for the hydrogen and the chlorine, and it should be given to you a value of 87.5 centimeter cube per gram mole. So that will be the VB. If you now calculated the VB, you can calculate the sigma B. If you calculated now sigma B, or A, sorry, it should be given to you as 5.24 angstrom. So that's that. Now you are able to find sigma AB because it is basically sigma A plus sigma B over 2. After sigma AB, you need to find the omega D. Omega D, if you go back to the equation, omega D, if you look on this slide, omega D is equal to some constants, and then you have the temperature star in it also. So constants are given to you. Only thing you have to find the T star. T star is K multiplied by T divided by the epsilon. Okay, the temperature, you have it, of your system. So it's only the ratio of K over epsilon AB. Epsilon AB, look at the top line of the equations. Epsilon AB is equal to square root of epsilon A multiplied by epsilon B. Okay, so what's the values of the epsilons A and epsilon B? One of them is easy, which is the air. Again, you come to this table, you'll see the air. The epsilon divided by K and unit of Kelvin is 97 for air. So you take it from the table, straightforward. So that's epsilon B divided by K. For the one that we don't have, which is the allyl chloride, you have to use the equation, third equation, which is epsilon divided by K, kappa, is equal to 1.15 multiplied by the TB. TB is given to you. The normal boiling point temperature for allyl chloride is TB 318.3 Kelvin. So now you have to put this value into the equation, so you will get the ratio of epsilon A divided by kappa. So now you got also this ratio. Okay, we don't know the value of kappa yet, and you don't need to do that. So now you are able to find the value of epsilon A B, which is equal to square root of epsilon A multiplied by epsilon B. You can now put the ratio of epsilon divided by K. Don't worry, because at the end, when you put it in the T star, it is a ratio of K divided by epsilon AB. So you don't need to find the value of K, the kappa. So if you do that, so you can find the value of T star. If you find the value of T star, that means the rest is basically constant. And then you can find the value of omega D. If you find the value of omega D, you can use now this equation straightforward. It needs some time for you to go through it, but these are the steps. The final value of diffusivity will be 0.0992 centimeters square per second. That will be the value of diffusivity that you will calculate it through this equation, and then you will find the percentage error when you compare the theoretical value with the experimental value, which was given to you as 0.098 centimeters square per second. That was the experimental value. So the error percentage, you will calculate it, and it will be 1.2%. These are the steps. You have to sit down, you have to do it yourself. And if you have any trouble, I suggest you use the chatting mechanism, which is in the Microsoft Teams. So if anybody has a question, don't come to me. You can even take it with your mobile, take your calculation, and put as a question, as an image in the chat. By that, people can, the one who have solved it, can help you. So have a good weekend, and I will see you next week.